Let's look at another example. In this case, we will try to find the number at the first index. Let's see what happens if we try to find the number 6, which is at index number 0. Binary search starts with identifying the start index and the end index. So since it's the same array, the start index is 0, the end index is 31. Binary search is going to calculate the midpoint, which is going to be 15. The number at the midpoint is 418, which is greater than the number we are searching for, which is 6. What does this mean? This means the number we are searching for cannot exist in the right side of the array this time. So this means there's no need to search anything beyond the midpoint. So binary search is going to discard the right half of the array. How does it do it? This time, since it is discarding the right side, it is going to move the end index. What is going to be the end index? It is going to be midpoint minus 1. Remember, when we are moving the starting index, it is midpoint plus 1. When we are moving the end index, it is midpoint minus 1. So the new start and ending index is going to be 14. A new midpoint is going to be calculated with 0 plus 14 divided by 2. 7 is the new midpoint. Now, the element at the midpoint is 116. The comparison is going to be done. And then we find out that the number we are searching for is less than the number at the midpoint. This means that the number cannot be in the right half of the array. Why? Because all the numbers on the right side of the midpoint are greater than the midpoint. And since the number we are searching for is smaller than the midpoint, then it has to be on the left side of the array. So in this case, we are going to move the end index again. So it's going to be midpoint minus 1. So our new start index is still the same. We don't have a new start index, but we have a new end index, which is going to be 6. So 0 plus 6 divided by 2 is going to be 3. So this is the new midpoint. Same comparison. You find out the number is still small, so we need to move the end index. It's going to be midpoint minus 1. So it's going to be at 2. The new midpoint is going to be 0 plus 2 divided by 2, which is going to be 1. Comparison is done, and we find out still the number is smaller, so we need to go left of the midpoint. So the end index is going to move midpoint minus 1, which is going to be 0. Now our starting index and ending index are same. So what is going to be the new midpoint? It's going to be 0 plus 0 divided by 2, which is 0. Now the number at the midpoint is going to be compared with the number we are searching for. In this case, we find that they both are equal. So in this case, we are going to say that the number has been found, and it has been found at index number 0. So in both scenarios, the first scenario we looked at the last index if the number that we are searching for is at the last index of the array, which means worst case scenario. In this case, we looked at if we are searching for a number which is at the beginning of the array, which means the best case scenario. Take a note of steps that binary search took in both cases. You don't have to find the exact number of steps, but a rough estimate would be nice. You can repeat this process and see how many steps it took in both cases.